Alright, let's look at the homework 1.3 problem number 7. Alright, so for given this function f of x and the g of x, we want to find the composition f of g. Alright, so let's do that. Alright, so part A, we want to find f of g of x. Alright, so this just means that f of g of x. So g of x is the inside function. Alright, so we just have to plug it in. So let's work from inside out. So this is going to be f of x plus 14 over x plus 2. Right? Then using the function notation, so every time you see x in the formula of f, we replace it by x plus 14 over x plus 2. Alright, so this is going to be equal to, alright, so plug it in. So I see x here, so we put x plus 14 over x plus 2. Alright, then plus 1 over x, so it's going to be plus 1 over, then you have to put x plus 14 over x plus 2. Alright, so since this is just a reciprocal, I would probably just write it as, so first one is, I'm going to leave it as it is. Alright, then we just take the reciprocal, so it's just x plus 2 goes up here, and x plus 14 is that. Alright, so I'm going to type that in. So I'm going to go back there. Alright, so this is going to be, so what we had was x plus 14 and divided by x plus 2 plus x plus 2 divided by x plus 14. Right? So this is the f of g of x. Right? How about the domain of this function here? So let's find the domain. Right? So in order to find the domain, right? So first, what's the domain of f? So we have to find domain of f. Alright, so domain of f is going to be all real numbers except for, because there's an x on the bottom, so we want that to be non-zero. So everything, all real numbers except for 0. 0 is the only bad number. Alright, and also domain of g. Alright, so you can see that when x equals -2, the denominator becomes 0. So we have to eliminate that. So we want x is not equal to -2. Right? So in order to find the domain of f of g, right? Remember, we have to have two things. One, x has to be in the domain of the inside function, in this case g, right? So which means that here one condition is, so x has to be not equal to -2. So x cannot be equal to -2, right? And 2, right? The function, inside function g of x, so g of x has to be in, this is a notation for in, the domain of outside function. So it's a domain of f, right? Which means that, let's see, g of x is this guy, x plus 14 over x plus 2, right? Since this is plugged into f function, so this guy has to be inside the domain of f. So which means that it's all real numbers except for 0. So we have to make sure that this is not equal to 0. which means that let's see, we multiply both sides by x plus 2. So we have x plus 14 is not equal to 0 times x plus 2 would be 0, right? Then we know that by subtracting 14, we want x is not equal to negative 14. Alright, so we have two conditions we need to satisfy, or in this case, two numbers we need to skip. So we need to skip a negative 2 and negative 14. Right? So therefore, we need to skip, go from negative infinity. So the domain of f of g is equal to negative infinity 2. Right, so we're gonna have to skip negative 2. So skip negative 2, and then we're gonna have to skip negative 14. Oh, actually, sorry, I messed it up there. All right, negative 14 is actually smaller, so it has to shows up first. So it's gonna be skip negative 14 and skip negative 2. Then go all the way to positive infinity. Right? So this is the domain of f of g. Right? So you can do the other parts very, very similarly. So I'm not going to go over that, but let's double check. We have the right solution. So here we have a negative infinity. Right? Go to symbol and infinity to negative 14. Then we're gonna skip negative 14. Then skip negative 2, and then go all the way to positive infinity. Right? So let's double check. So I'm gonna go down and submit for testing. Alright, it came back, and looks like we got part A correctly. Alright, so all you have to do is very similarly making sure, so part B, f is the inside function, part C, f is the inside function, and f is the outside function as well, and g is the inside function, and g is the outside function as well. Alright, that's it. I hope that this was clear.